In this video, we'll be looking at how to solve a system of linear equations graphically. First, let's talk about what a system of linear equations is. A system is two or more linear equations that are solved simultaneously. Now, we'll be looking at just two equations in this class, but do know that you could have more than two linear equations that are being solved. And you see an example here. These are two linear equations. These should look familiar to you. And sometimes you'll see this bracket that is surrounding them that just shows that those two equations go together. Some textbooks leave it out. Now, before we start to talk about exactly what to do when you're solving a system, let's talk about what the solution of the system should look like. Well, first I want you to remember that a graph line is a picture of all of the solutions to one linear equation. And that line is made up of infinitely many points. So for one equation, there are infinite solutions. Now, if we're looking at the solution to a system of linear equations, we want the one point that will sit on both lines at the same time. Now, once we graph our two lines, we'll see that this point is the intersection of those two graph lines. It's the only point that those two lines will share. Alright, so when we're solving a system graphically, the first thing we're going to do is graph both of the lines on the same set of axes. And you can use any of the methods for graphing that you've learned. So you can use the slope y-intercept form, you can find the x and y intercepts, or you can make a table of values. Whatever you need to do to get your two lines down is what you need to do. At that point, once you have your lines graphed, you're just searching for the point where the two lines intersect. I want you to circle that point or indicate it to me in some way, as you see in this picture with the dot plotted, and also label with its coordinates. So in this picture here, the point of intersection has coordinates 1, 5. Now, it's very important that you actually do show where the two lines intersect and you state the coordinates. Otherwise, you're not answering the question and giving me the solution. You're just drawing me a picture of two lines. Alright, so here are 3 examples that I want you to try, and you have these examples on your worksheet. So I want you to take a second, hit pause, graph these 3 systems, find their points of intersection, and then when you're done, come back here and I will go through how to graph them. Okay, at this point you are hopefully done with your graphing, and I wanted to give you an example from the beginning. Hang on one second. Okay, it seems like my player was playing without me, so here we are back at the beginning. So this is the first system that you have on your sheet, and the first thing I'm going to do for each equation is state the y-intercept and the slope for each one, so I get a sense of where to start. So for the first equation, my slope is 4 over 1, which means I move up 4 and 1 to the right, and my y-intercept is 3. For the second equation, the slope is negative 1 over 1, which means I go down 1, 1 to the right, and my y-intercept is negative 2. Now, going to my graph for the first line, I'm going to begin at 3 on my y-axis. So I'll plot that point. And then from there, I'm going to go up 4 units and 1 unit to the right. So 1, 2, 3, 4, 1 to the right. Now, since I'm off of my graph, if I keep going, I'm just changing my direction here to go down 4 units and 1 to the left. So see that my next point will be here. And I'm just going to go ahead and put one more point just so I can really see where that line sits. So I went down 4 more units and 1 to the left. Now I'm going to pick up my straight edge here so I get a good line. When you're graphing linear equations, it's really important that you actually have an accurate graphing system. So my hand-drawn coordinate plane may run me into some trouble if my intersection is not perfect, but I could always check my solution. So you shouldn't have any problem with this on your graph paper. So here I have the first line graphed, and I'm labeling it with its equation. Going to the second line, I'm beginning at -2 on the y-axis. And from there, I'm going down 1 unit and 1 unit to the right to plot my next point. And then I'll continue that to get a third point. And I could go the opposite direction to get my fourth if I wish. And once again, I'll pick up my straight edge so I get a pretty decent line. Notice that I'm extending my lines the entire coordinate plane. I do want to make sure that they intersect. And this is my equation, y equals -x minus 2. All right, now again, I'm not done because I haven't answered the question. I need to find the point of intersection, which is right here, and I will label it with its coordinates, which are -1, -1. So now the solution to this system of linear equations is the point -1, -1. All right, going on to the second example, I have my equations here. The first one, notice, is y equals -1. This is a horizontal line. There's no x coordinate or no x variable shown in that equation. The y-intercept is the point 0, -1. And for the second line, my slope is -5/2, which again means down 5, 2 to the right, and my y-intercept is 4. All right, starting with the first line, the horizontal line, I'm going to plot a point at 0, -1, and then just draw that horizontal line passing right through that point. Remember, for a horizontal line, the slope is 0. Okay, now for my second line, I'm beginning at +4 on the y-axis, and from here I'm going down 5 units, and then 2 units to the right. So I'll see that point lands right on the line that I've drawn before, which tells me that that is my solution. However, I'll draw a third point just so I get a good picture of that line. And take my straight edge here and connect these 3 points. Usually 3 points is enough to get a good sense of where your line is when you're drawing. Technically you only need 2, but I find that when you're graphing by hand, 3 really helps you to get a better sense of where your line sits. Okay, now after labeling these 2 equations, I still need to label my intersection, which is answering the question, and state the coordinates, which are +2, -1. So therefore my solution to this system is the point 2, -1. Okay, hopefully we're doing okay so far. Let's move on to our last example. The first equation has a slope of +3/1, which means up 3, 1 to the right, and the y-intercept is -4. The second equation has a negative slope, -1/2, which means down 1, 2 to the right, and the y-intercept here is 3. Now going to the graph for my first line, I'm going to begin at -4 on the y-axis, and from there move up 3 units and 1 unit to the right. And I'll do that once again, so I get my third point, and then pick up my straight edge and connect these 3 points to make the line. Again, I'm extending my line. I don't want little teeny tiny lines. I want them to extend across the entire grid space that you have. Labeling the equation. Notice again I have arrows at the end. That's important as well. This line is infinite. And going to my second line, I plotted the y-intercept at 3. And then I'm going down 1 unit and 2 to the right to get my second point. And once again, down 1 unit, 2 to the right to get the third point. So I already know where these lines intersect, but of course I'm going to draw the line with my straight edge. Make sure to label the line with its equation. But of course, I'm not forgetting to show the intersection, because if I forget to show the intersection, I haven't answered the question. So my solution to the system is 2, 2. Okay, so hopefully you did well on these 3 examples. I want to again draw your attention to your worksheet where you should have your rules for linear equations, how to solve, written down. So if you need to, pause right here and make sure that you have your steps written down on your worksheet. And in addition to that, you have a question on the bottom of your worksheet that is asking you if you think that any system of equations always has a solution, and to explain why you think it does or why you think it doesn't. So this concludes our video on how to solve systems of linear equations by graphing. We will be looking at 2 algebraic methods in class that will be a little more involved. So the graphing is actually the easiest of the 3 for us for now. Alright, so if you have any questions, we will address it together. Hopefully you found this video useful.